About to get started with practicing multiplying with the standard algorithm. This is lesson 4, session 3. This is our last piece of homework for this week. We are going to start with question number 1. But before we get started with question number 1, let's look at the example, which tells us how to use the standard algorithm. Standard algorithm is the old school method where you put the big number on top and the little number on the bottom. Our little number is 32, and the number in red is 30, and the number in blue is the 2 in the ones place. So this is the ones, and this is the tens. So this represents 30, and this represents 2. They want us to follow these partial products, the ones, and then the tens. Sorry, I said 2. The tens, and this is the ones. Once you get the partials for the ones and the tens, you add the numbers up. All right, we got my students here today. They're going to help me solve this problem. Number 1, it's already been set up for us. We just need to make sure we find the way that works best for our problem. I'm going to go ahead and check and make sure they did this problem right. 6 times 4. 24. And then we have, look, there's 0 times 4. 0. Then we have 200 times 4. 800. Then we have 1,000 times 4. 4,000. Now we add all those numbers up. And again, I will switch this. I'm going to do 4,824, then 0. This is me just focusing on my ones. Again, just focusing on my ones. In the ones place, 0 plus 0 plus 4 plus 0 is 4. 0 plus 0 plus 2 is 2. 0 plus 8, 8. And we drop that 4 down. We get 4,824. Would you look at that? That is my ones. So far, they did this problem correct. Now, for those struggling to see, I'm going to zoom in on the screen. Now, we're looking for the expression. Expression is an equation without a what? What is an expression missing?
Without an equal sign.
It's missing the equal sign. We don't have one of these, so this is why it's not an equation. All right, this was pretty simple. If we solve this, it would be, we're going to drop 2 zeros behind that, 126 with 2 zeros behind it. If I did this problem, it would be 1,206 add 1 0 behind it, because you drop a 0 when you multiply the tens. So that ends up being that. This ends up being that. This one right here is 14 times. So this one is I'm going to need to decide between these two. Now, we just did 4 times 1,206. This is 4 times 6. Okay, that's what that is equal to. They want to find out, how do I get 12,060? So we can cross this out. Oh, I think I see my answer. Does that match?
Yes.
Well, you know, this one doesn't match, because this is 126. This is 1206. So we can cross out A and D. Now it's time for us to do the next one. We're going to do 1,000 plus 200 plus 6. And what's our number in the tens place? 1. So this is going to be times 10. because we already solved for the 4. Now we're just going to solve for the 10. So now we're doing the 10s over here. We already have an answer. I'm going to tell you right now, C is an answer. But I'm just going to make sure I eliminate it, because this whole thing right here is my problem. That's B. And the answer for B is 16,884. But just so we can show our work, this would be 1,000 times 10. It's 10,000. Because there's 1, 2, 3, 4, 4 zeros. So 1, 2, 3, 4 zeros. 200. And then I'm going to drop another 0 behind 200. I get 2,000. 6 times 10 is 60. You put that together, what do you get? Yep, 12,060. And so the answer is C. Now the easiest way to do it is a process of elimination. Just go ahead and solve all those. And I went the longer way just to make sure I check my work. This you don't necessarily have to do. You can easily just solve each one and cross them out. So we know it's not that one either. This is the answer for this one. All right, let's move over to the back. We're going to start on problem number 2. Find the product of 512 using the standard algorithm. Oh boy. Estimate to check your answer for reasonableness. So that means I'm going to have to round. All right, round to the nearest numbers. Let's go ahead and set up our problem. We're doing 512 times 46. We could do an area model. It would be a lot faster. And you know what? I am not judging you guys. If you want to do the area model, by all means do the area model. But we do want to do what the problem said, the standard algorithm. On your own papers, go ahead and do the area model. But as the teacher, I am going to model the correct way to use the standard algorithm. Big number on top, little number on the bottom. Now I am going to solve for the ones place. The one is place is going to be doing 6 times 2. 6 times 2 is 12. I'm going to put the 2 here, and I'm going to carry my 1. Then I'm going to be doing 6 times, technically this is 10, but we'll just say 1 because we're carrying. 6 times 1 is 6 plus 1, 7. Then we go 6 times 5. What's 6 times 5? 30. And you just put the 30 here because you're at the end. Now, we drop a 0 in.
We multiply the 10.
Now we're going to the 10s. Remember, these is the 1s. Now I'm about to do the 10s. All right, first number in the 10s is 4 times 2. What's 4 times 2? 8. 4 times 1. 4. Ooh, this is real easy. 4 times 5. 20. And since there's nothing else left, you put the full 20 there. Draw your line. And what's the last thing to do, class?
Add the numbers up, and that's the product.
All right, a little rusty, but you're there. 2 plus 0 is 2. 7 plus 8 is, it's not 16, it's 15. Carry my 1. We're going to do 1 plus 4, 5. 3 plus 0,
3.
and then just drop your 2 down. So what's my answer?
23,552.
So the answer is 552. All right, let's now move on to problem number 3. When using the standard algorithm, find the product of 5,917 times 29. The first step of multiplying 9 times 1, 9 times 7 is already done. Oh, look, they did do it. What is 9 times 7? It is 63. So you see they put the 6 here and the 3 here. Explain why you regroup before doing the next step. Well, we know that we have to do the ones, and we are carrying them because they're moving to another place value. So here we regroup because of the place value can only hold. How much can a place value hold? What's the maximum before you have to round up? No, in each place value, it can't be no more than 10 per place value. That's why you drop a 0 in. So it's up to 10. And then you carry. It really is 9. So. It was a few seconds. For us, it was 5 minutes. But we're back. Let's get back into this problem. So for the ones, they did 9 times 7, which was 63. They carried the 6 to the next problem. So now we have 9 times 1 plus 6. What do you get when you do that? 9 times 1 is what? 1? No, 9. 9 plus 6. 15. So now that we got 15, we're going to have to carry the 1. Now we move on to the next one. This is 9 times 9. 9 times 9 is... Come on, guys.
81.
81. And 81 plus 1? 82. So now we're going to put the 2 and we're going to carry the 8. And now we have the last one. 9 times 5. What's 9 times 5? And then plus 8. 45 plus 8. 53. And put all that right there. Now we drop a 0 in. I wish they would have gave me just a little bit more space in this problem, but I'm going to try to squeeze it in. 2 times 7. I don't even know where I'm going to put it at. I should have just... If you got room, 2 times 7. 14. Am I the right tiny? Put a 4. Carry the 1. The only problem with the standard algorithm is the space. I was supposed to put it over here. Ah, shucks. 2 times 1 plus 1. 3. 2 times 9. 18. Carry the 1. And 2 times 5. Plus 1. Now we add all this up. You get 3, 9, 5, 11, 6, 7, 1. So the answer is 17,593. Whew, sorry it's so tiny. All right, moving on to problem number 4. What is the value of the regroup 1 above the multiplication problem? So let's look at the problem. Does anybody see the 1 in this multiplication problem? What number is it above? In the thousands place, which is a 7. So we need to look at the number next door to that, which is 5. All right, and since it's at the bottom row, that means it was part of this problem. 2 times 4 gave us 8. 2 times 0 gave us 0. 2 times 5 gave us 10. 10, yeah. And then it carried the 1. Oh, so it was 2 times 5, which gave us what? 10. So what is the value of the regrouped 1? Is it from the hundreds or is it going to the thousands? Question. Let's take a minute to think about it. It came from 5. Technically, it was 500 times 2. And what did we get? 1,000. So what's the answer? As long as you improve, that's okay. All right? Because this is a 5 in the hundreds place, and that is the 2. And that is where the 1 came from here in our problem. All right. Let's now continue to the last problem. The base of a garden. Uh-oh. Looks like we're looking for volume. You don't have to draw the shape. I'm just doing it for visuals. Sometimes I need to see my problem. All right. The base, so we're going to be doing base times height. The base has an area of 27,405 square meters. Woo! That's intense. Its height is 18. Oh my goodness, we're doing 27,405 times 18. What is the volume? It's just an extra digit, y'all. Now, it says use the standard algorithm. Class, you have my absolute permission not to use the standard algorithm. I mean, I would take the biggest number and do what? Expanded form. So 20,000 plus 7,000 plus 400. Ooh, we're going to have to do a lot of adding. And since there's nothing in the tens, it's just going to be 5. And we're going to take 18 and we're going to put it over here as 10 plus 8. Now we're going to drop our columns in here. And this is 20,000 times 10. 20,000 times 8. 7,000 times 10. 7,000 times 8. 400 times 10. 400 times 8. 5 times 10. 5 times 8. Let's start with our easy numbers. 5 times 10, 50. 5 times 8, 40. What about 400 times 10? Well, anything times 10, you're going to drop a 0 in. You multiply the tens. So now that becomes 4,000. 4 times 8 is 32. How many zeros do I put behind that? 2. 7 times 10, if that's 7,000, this now becomes 70,000. And 7 times 8? 7 times 8 is 56. How many zeros do I put behind it? 1, 2, 3. And now we have 20,000. This is 20,000. This now becomes 200,000. And this is 20,000 times 8. Well, 2 times 8 is 16. Now I got to put 1, 2, 3, 4 zeros behind it. Wow. This Problem is humongous. Now, the shortcut I learned would be to combine all of these up. And that would give me 274,050. And this one would be, this one you gotta do a little bit of math, because you're combining 160 plus 56. What's 56 plus 160? This one you actually gotta add up a little bit. I'm gonna add it over here to the side versus trying to do it in my head. I'm a boss, but I also want you guys to see the math. Big brain energy. So what I get when I add those up, I get 4, I get 2, I get 9, I get 11, I get this. So now I got my final product. Sorry if you guys can't see it. All right, and my answer here is 0. 5 plus 4 is 9. 0 plus 2 is 2. 4 plus 9 is?
12.
She says 13. I don't believe her. 10, 11, 12, 13. Oh my goodness, Liera, you're so smart. 7 plus 1 plus 1? 9. And 2 plus 2? 4. So my total for doing 27,405 times 18 is 493,290. Right is right.
Wrong is wrong.
Please make sure you show your work. And don't forget, don't lose.
Don't lose.
Bring your homework to school tomorrow. If you need to, play this one back. Everyone say bye.
Bye.